I will be talking behind the science of marinara sauce and meatballs. Starting off with the science behind meatballs, raw meat is usually tasty rather than flavorful. It provides salts, savory amino acids, and a slightly acidity to the tongue, but offers a little weight in the aroma. Cooking intensifies the taste of meat and creates its aroma. It's a simple physical damage to the muscle fibers because them to release more of their fluids and therefore more stimulating substances for the tongue. And the fluid releases at its maximum when meat is only lightly cooked or done rare. When the temperature increases, it dries out and the physical change gives way to the chemical change and to the development of aroma as cell molecules break apart and recombine with each other, form new molecules that not only smell meaty but also fruity and floral, nutty and grassy. When it comes to the color of the meat, it changes in two different ways during cooking. It's usually translucent because the cells are filled with loose meshwork of proteins suspended in water. So when it's heated about 120 Fahrenheit, it develops a capacity as heat-sensitive myosin denaturate and coagulates into clumps large enough to scatter light. And then when it's around 140 Fahrenheit, the red myoglobin begins to denature in tan-colored version. And as this change proceeds, the meat color shifts from pink to brown-gray. So in comparing it, when you mix ground meat with breadcrumbs and seasonings, you're creating a mixture that needs to stick together and cook evenly. And the breadcrumbs absorb moisture and swell, which helps to keep the meatballs moist, and the proteins in the meat and eggs coagulate when heated, helping the meatballs to hold their shape. As the meatballs cook, the Maillard reaction occurs, and this is a chemical reaction between the amino acids and reducing sugars that give brown food its distinctive color and flavor. The reaction is what gives meatballs that delicious savory crust on the outside while keeping the inside so tender and juicy. And since we're cooking it on high oven temperature, which is 400 Fahrenheit and above, the meat surface quickly browns and develops the characteristic roasted flavor, and cooking times are short. So now let's talk about the science behind the thickening sauces with emulsions. Since we're making marinara sauce, these sauces are liquids thickening with a fine dispersion of solid materials, protein molecules, starch granules, and particles of plant tissue. But there's another method to thickening sauces, which are emulsions. An emulsion is created when a water-based liquid is filled with droplets of oil. These oil droplets are much more massive and slow-moving than individual water molecules. They impede the motion of water molecules, creating a thick and creamy consistency in the mixture. The term emulsion comes from Latin word meaning to milk out, originally referring to the milky fluids pressed from nuts and other plants. Natural emulsions include milk, cream, and egg yolks, while sauce emulsions include mayonnaise, hollandaise sauce, and Beurre Blanc, and oil and vinegar salad dressings. Modern chefs usually take the concept to new heights, using emulsions to thicken all kinds of liquids, often highlighting the term emulsions on their menus. However, the emulsified sauces present a special challenge. Unlike sauces thickened with solids, emulsions are inherently unstable. For example, when you whisk oil and vinegar together, the vinegar from droplets in the oil, but when they soon sink and then coalesce, causing the two liquids to separate. Cooks must not only form the emulsion, but also prevent it from breaking apart due to the basic incompatibility of the two liquids. And this is also the final